Derivatives. A very long word that has a long definition. Limit of the ratio of the change in a function to the corresponding change in its independent variable as the latter change approaches zero. Simply put, though, a derivative is defined as the slope of a function at any point. For example, the derivative of the line f of x equals 2x is 2. By the way, we can express derivatives several different ways. By dy over dx, d over dx, and f prime of x. What happens when the graph is not linear, like f of x equals x squared? The derivative of the line f of x equals x squared is 2x. Trig Identities. Before we go into the rules of derivatives, we are going to go over some important trig identities. These identities can be derived, but it's extremely useful to remember them for quizzes or tests.
You just want to go to the next slide, or do you want to read the trig identities?
I'll read them, I guess. So, for some trig identities, there's d over dx of sine x, which is the derivative of sine x, equals cosine x. The derivative of cosine x equals negative sine x. The derivative of tangent x equals secant squared x. The derivative of cotangent x equals negative cosecant squared x. The derivative of secant x equals secant x times tangent x. The derivative of cosecant x equals negative cosecant x times cotangent x.
Don't read the inverse, just say they're complicated so you can look them through.
The inverses are quite more complicated, so study them yourself. Now we will go over some rules. First is the power rule. As shown on the first graph, the derivative of a constant multiplied to a variable is the constant. For example, the derivative of y equals 3x equals 3. But what do we do when the function isn't linear? Well, the power rule is your friend. The rule is derivative of x to the nth equals nx to the n minus 1. For example, the derivative of f of x equals x to the fourth, so n equals 4, which is the exponent, and then n minus 1 equals 3, so the derivative is 4x to the third. Next is the sum and difference rule. What do you do when you have a polynomial as a function and you have to take the derivative? Well, you can split up each part of the function and take the derivatives separately. The sum rule is the derivative of f of x plus g of x equals f prime of x plus g prime of x. The difference rule is similar. It is f of x minus g of x equals f prime of x minus g prime of x. For example, the derivative of 3x to the fourth plus 8x to the second minus 5 is 12x to the third plus 16x minus 5. It's not in the right order, that's why. Next is the chain rule. First of all, don't mix up chain rule with product rule. Did we skip product rule? Because product rule is first on this.
Here. Okay, then we'll go back to chain rule.
Okay.
It's fine.
So, because it mentions it before. Okay, so what to do if you have two functions multiplied to each other? The product rule would help you immensely in this case. F of x times g of x equals f of x times g prime of x plus g of x times f prime of x. For example, the derivative of x to the third times 4x to the third plus 32x equals x to the third times 12x squared plus 32 plus 3x squared times 4x to the third plus 32x, which equals in total 24x to the fifth plus 128x to the third. Next is the chain rule. First of all, don't mix up the chain rule with the product rule. The chain rule is applied when you have a function inside of a function, like f of g of x. The chain rule is the derivative of f of g of x is f prime of g of x times g prime of x. For example, the derivative of x squared, the derivative of 5 times x to the x squared plus 6. Oof. Give me a second. Okay, for example, the derivative of 5 times x squared plus 6 to the 7th as a whole is 7 times 5 times x squared plus 6 to the 6th as a whole times 10x, which totals 70x times 5x to the 2nd plus 6 to the 6th. They don't match up. Oh, this is the quotient rule? Okay. Well, now... Okay. Now use the product rule and chain rule to derive the division rule, which is the quotient rule. The quotient rule is the derivative of f of x over g of x equals f prime of x times g of x minus g prime of f of x, g prime of x times f of x all over g squared of x. For example, the derivative of 7x divided by x squared plus 1 is, excuse me, 7 times x squared plus 1 minus 2x times 7x divided by x to the 4th plus 2x to the 2nd plus 1, which totals negative 7x to the 2nd plus 1 divided by x to the 4th plus 2x to the 2nd plus 1. Another rule that is very helpful is the exponential rule. So here's some rules pertaining to the specific functions. Exponential functions. For example, the derivative of e to the x is e to the x. The derivative of a to the x is a to the x ln a. Don't get those two confused. The derivative of e to the x to the g of x equals e to the g of x times g prime of x. The derivative of a to the g of x equals the derivative of a to the g of x equals ln a times a to the g of x times g prime of x. For example, the derivative of f of x equals 3 times 2x plus 1 equals ln 3 times 3 to the 2x plus 1 times 2. Next is the logarithmic rule. Logarithmic rules are slightly different. For example, the derivative of ln of x equals 1 over x, but only when x is greater than 0. The natural log of g of x equals g prime of x over g of x. The log of base a times a to the x equals 1 over x ln a, only when x is greater than 0. And the log of base a times g to the x equals, oh, I said that wrong. The log of base a g to the x equals g prime of x over gx ln a. For example, the derivative of log base 11, 8x squared plus 5 is 16x divided by log base 11, 8x squared plus 5 times the natural log of 11. Now take a moment and try these problems. Pause the video now.
Oh, okay.
No, the audio's been going.
Yeah, okay.
Whenever you're ready. The answers are, for number 1, the derivative of 4x cubed plus 49x plus 23 is 12x squared plus 49. For number 2, the derivative of x squared plus 3x plus 1 divided by 7x is x squared minus 1 divided by 7x squared. For number 3, the derivative of cosine of 8x squared is negative 16x sine 8x squared. For number 4, the derivative of e to the x times 2 to the x is e to the x ln 2 times 2 to the x plus e to the x times 2x. For number 5, the derivative of cotangent of arcsine of x is negative cosecant squared of arcsine x times 1 over square root of 1 minus x squared.
And that's all.
And that's all. You guys have a good day.